Hello everyone, welcome to 1bit channel, and in this video we are going to talk about bases. The first question comes to mind is, what is a base? A base is a numbering system, a method for forming and counting numbers, a convention for writing and naming them. Well, what we mean by that is a base is just a combination of numbers, a set of numbers. For example, base x is a base that contains three numbers, 0 and 3 and 5, for example. And it's a method for forming and counting these numbers. So we could say 1 plus 3 equals something. And a convention for writing and naming them. So each number we give it a name. For example, 1 we give it a name for 1 1. That's basically it. Let's see some examples, some well-known examples. The first example here is base 10. Base 10 includes numbers from 0 to 9, so 0, 1, 2, 3, 5, etc. until 9. The base name is 10, so it includes 10 numbers. So 1 to 9 is 9, and 0 is 10. It is used for counting numbers in our daily life. We use this base in our daily life. Every number we know is between 0 and 9. Well-known base by us, by the majority of people, is base 16. Numbers included in this base are from 0 to 59. It is used for counting hours, minutes, and seconds. The convention we give to this base are, for example here, 1 minute equal to 60 seconds, and 1 hour equal to 60 minutes, and 1 day equal to 24 hours. Another base is base 12. Numbers included in this base are from 1 to 12. It is used for counting months, years, and quarters. For example, month number 1 is equal January, number 2 equal February, and 12 months equal 1 year, 3 months equal 1 quarter. Another base that's well known is base 2 or binary. Numbers included in this base are from 0 to 1, so just two numbers. It is used in computer science and electricity. 0 equal to false or off, or 0 means that there is no value or there is no electricity. 1 equal to true, or there is a value, or it's on, or there is an electricity. That's simple. Now, how a base work? Let's see how bases work. In our first example, we'll see how base 10 works. The simple rule, I divide to two parts. This is the part 1. We will see just increasing by 1 or decreasing by 1. We know that base 10 previously, that base 10 include numbers from 0 to 9, so 10 numbers. If we say that x equal to 1, and we will increase this x by 1, okay, and equal to, so x plus 1 is equal to, so now x is equal to. What we did here, we add just one step. We add 1, so just one step. Previously, this x is equal to 1, so x was here, and we add one step, so we go to the next element. Now x is equal to in this index. If we add another 1, we'll go to the next element. Simple as that. If we say decreasing, now x is equal to 3. If x minus 1, so it's 2. If we minus another 1, we will get 1. If we get minus 1, we will get 0. Okay, this is the first simple rule. The part 2 of this simple rule, we are going to use the same numbers, of the base 10. And let's say now that x is equal to 9. Okay, and we want to increase plus 1. So we know that 9 plus 1 is equal to 10. But how do we get this 10? From where? We know that base 10 is including only numbers from 0 to 9. So 10 is not a number here. We reach the last element in this base. So what we did, this equation, so 10, we are adding just one step. So 9 plus one step, we are out of numbers. So we get back to the first element. This thing that we get back to the first element is called a round. Okay, a round is this one. It's just one round because we return to the first element, so we add one in the left. And how many steps do we add? Just one step. So the first element after 9 is 0. That's why we got 10. Let's see another example. X is equal to 9 plus 5. 9 plus 5, we know that it is 14. So if we add 5 to 9, it's the first one here is 0. So 1, 2, 3, 4, 5. 5 steps after 9 is 4. And we did another round. That's why we got 14 here. Let's see that in action. So we back to 0. And from 0 to 1, that's 2, 3, 4, 5. So that's where we got 14. And this one here is just for the round. I hope you get this simple rule right. Okay, now let's see base 2. How base 2 works. It works like base 10 and any other base work the same way. So in base 2 we have just only two numbers, 0 and 1. If we say that 0 plus 0 is obviously 0, 0 plus 1 is equal 1, and 1 plus 1 equal what? We add another step, so 1 plus 1, so one step after this one is 0, and we add the round number. It's just one round because we back to the left just one. Okay, if we say 11 plus 1, how many? What is the result of this number? If we say 11 plus 1, 11 plus 1 equal 10 plus 10, 10 plus 10 is equal 100. From where we got this? 1 plus 1, we know that it equals to 10. Okay, so 10 plus 10. Because if we divide 11 into two parts, it's 11 equals 10 plus 1. So 1 plus 1 is 10, and the other 10 is 10 plus 10. 10 plus 10 is equal 100. From where we got this? 0 plus 0 is equal 0. 1 plus 1 is 10. 1 plus 1 here, 1 plus 1 is 0, and the round is 1. So 10 plus 10 in base binary is 100. 1 plus 1 in binary equals to 10. Let's see base 16, called also hexadecimal base. We have this set of numbers from 0 to 9, from A to F. Okay, 0 plus 0 is equal to 0, 0 plus 1, 1, etc. But 9 plus 1 equal A, because the next element, the next number of 10 is of 9 is A. It's not 10, it's A. Okay, and A plus 1 is equal to B. So we keep increasing, and if we are of number, for example, F plus 1 is 10. So F plus 1 in B16 is 10, because we add 1, the first value in the element is 0, and we did one round. Okay, I prepared for you a demo. Let's see base 10 in action. We will keep increasing. Okay, base 10 we know how it works. So 0 plus 1, 1, 2, 3. We keep increasing 4, 5, 6, 7, 8, 9, 10, 11, 12. We all know this counting number. Okay, we will see now how base binary, base 2, and base 16 work. So now to base 2. The first element is 0, and the second element and the last one is 1. If we will keep increasing the numbers. So the first is 0 plus 1 equal 1 plus 1 equals 10 plus 1 equals 11 plus 1 equals 100 plus 1 equals 101, 110, and so on. If you want this example, let me know in the comments. I can share it with you. So now to base 16. We'll see how it works in action by increasing the numbers. First number in base 10 is 0, plus 1, 1, plus 1 equal 2, plus 1 equal 3, 4, 5, 6, 7, 8, 9, and the next element is A, B, C, D, F, E, F, and the next element we know that is 10, 11, 12, 14. I will keep increasing until you understand how this base works. And the next element now, can you guess? Yes, it's 20. And we keep increasing the same way. I hope you understand how counting numbers in general work. Okay, we see another example is base 60. Base 60, we know it all. I set a timer here to keep increasing. So these are seconds, here are minutes, here are hours. All right, we reached the end of the video. We'll see part 2 soon. I'll upload it after this one. I hope you enjoyed the video and stay tuned for more.